In this video we're going to talk about ionic bonding. So we'll start by talking about something that we've already learned about, which is valence electrons. Okay, remember the little shortcut we learned to figure out how many valence electrons something has? So everything in this group, the alkaline metal group, has 1. Everything in the alkaline earth metal has 2. And then 3, 4, 5, 6, 7, 8. So the number of valence electrons is going to be an important first step towards forming ionic bonds. So make sure you remember how to do that. So now we're going to write something called a Lewis dot structure. Okay, so you look at the number of valence electrons something has, all right, and lithium has 1, so we're going to put 1 dot on it, and that's the Lewis dot structure for lithium. It shows its number of valence electrons. For beryllium it has 2, so we're going to put 2. The first 2 always go together. Okay, that's the S2 electrons. And then after that, we're going to follow Hund's rule. So boron has 3, so we put the first 2 together, and then we put 1 there. Carbon has 4, first 2 together, and then 1 on each side. Nitrogen has 5, first 2 together, 1 on each side. You see the pattern here? Oxygen has 6, so the first 2 together, and then 1, 2, 3, and then we can double up. Okay. Fluorine has 7, so 2, 1, 2, that's 5, 6, 7. Okay. And neon has 8, so we'll give it all 8. So it just shows the number of valence electrons in an atom. So, well, what do we do with that? Well, an ionic bond is an electrostatic attraction. That just means the attraction between a positive and a negative. Okay? So it's between the cation, which is positive, and the anion, which is negative, that results from a transfer of electrons from the metal to the nonmetal. Okay? So metals transfer electrons to nonmetals. Metals lose electrons and become cations. Nonmetals gain electrons and become anions. And then that positive and negative are attracted to each other, and that's called an electrostatic attraction. And that attraction is called an ionic bond. So if we look at sodium and chlorine, you'll see that I wrote their Lewis structures, and we're going to show that transfer of electrons. Sodium has 1, and it's going to take it and it's going to give it to chlorine. Well, why does it do that? Well, it does that because by losing an electron and forming Na+, it's just like neon, okay? It becomes isoelectronic with neon, so now it's really stable and happy. Stable, don't say happy, okay? Over here, now chlorine has 8 electrons, so instead of chlorine, it's chloride, and it's happy or stable like argon, okay? So this is called the octet rule. Metals lose electrons to be like a noble gas. Nonmetals gain electrons to be like a noble gas. And then Na plus and Cl minus make NaCl. Okay? What happens if we have barium and fluorine? So barium is an alkaline earth metal, so it's got 2. Fluorine's got 7. Right, valence electrons. So can you see that barium's going to give 1 of them to this fluorine and 1 of them to this fluorine. So now we've got barium ion. Okay, lost 2 electrons, so we say Ba2+. Okay, and now it's isoelectronic or just like neon and happy. Okay, and these guys form fluorides. Okay. So they're just like neon and happy. Okay, so that's the octet rule. They've got 8, 8, 8. Now I have 1 barium and 2 fluorides. So the formula this forms is BaF2. Okay, because I have 1 barium and 2 fluorides. So BaF2 is the ionic compound that barium and fluorine form. So what will aluminum and oxygen do? So we'll start with aluminum, which has 3, and we'll start with oxygen, which has 6. Okay, so we'll start transferring electrons. So 2 of them we're going to go and make this oxygen happy, right? We're stable. But this still has another, aluminum still has another electron, so we need another oxygen here. Give it 6, so it's going to give it to here, but it still needs another one, so I'm going to make another aluminum, okay? So it can give one of its electrons, so now this oxygen becomes oxide, okay? And this is an aluminum ion. And can you see maybe we're almost done? I've still got 2 electrons to get rid of, so I need one more oxygen. So one of them goes here, and one of them goes here, and I've got another oxide, and I've got another aluminum. So all of that matching up of electrons leaves me with 2 aluminums and 3 oxygens. So Al2O3. Okay, in the next video we'll take a minute and we'll learn how to name those compounds, which is really, really easy.